Okay, so we got a Venn diagram again. Clearly, the circle on the left represents the people on the tennis team, and the circle on the right are the people on the soccer team. All 14 people, as it says, are in Miss Ward's class. Okay, so okay, I did all that. Okay, so then it says, let's go find the probabilities. Okay, oh, and then there's Bob here, who is not in Miss Ward's class, and he's not in the tennis or the soccer team. Okay. So find the probabilities of the events below. All right, probability of A. So A is, you can pick somebody random from the tennis club. Well, there are 1, 2, 3, 4, 5, 6, 7, 8 people out of these 14 on the tennis club. I don't know if you can hear that beep. That means the cookies are ready. I just saw Top Gun Maverick. Oh my gosh, that was awesome. Okay. Probability of B. So there are 1, 2, 3, 4, 5, 6, 7 people in group B, the soccer club, as defined right there. Okay, 7 out of 14. I can write that, or I can just say 1/2. Either way is fine. All right. Probability of A and B. So how many people, or what's the probability I pick somebody who's in group A, tennis, and group B? So he's in both groups. Well, there are 2 people in group A and group B, Tony and Josh. So that's going to be 2 out of the 14. Yeah, 14. Now, this symbol here we haven't seen before. See this little vertical line in the middle? That suggests conditional probability, like we saw in the last video very briefly. So what this means is, what's the probability that event A occurs given that event B has already occurred or will occur? So, so here's one way of looking at it. Okay, you can say, all right, what's the probability? Let's see, it was that. Okay, so what's the probability that we pick somebody from group A, given that we will pick somebody from group B? So we're going to pick one of the people circled up. So what's the probability that we actually pick somebody that's in group A? Well, we're down to just 2 people in group A out of 7. Okay, there. So the second letter is the condition. That's what is definitely going to happen. And so we say, all right, based on that, what's the probability we pick somebody from A? 2 out of 7. Okay. So now I gotta figure this out. Okay, so 2 out of 7. There's a formula for doing this. I find it easier just to do it this way, to be honest. Okay. Now this one says, hey, what's the probability of event B multiplied by the probability of A given B? We've already got all of that. Okay, darn right. We already know that the probability of event B is 1/2. And we know that the probability of A given B is 2/7. And the 2's cancel, and we just get 1/7. Okay, so that's kind of how it goes. Now, what just for practice sake, what else we got? Yeah, just for practice sake, where's the clear button? I get rid of that stuff. For practice sake, if I said, all right, well, what is the probability of B given A? All right, pause the video right now, and then and try to figure it out on your own. I hope you paused it. Okay, because here I go. So this says, what's the probability of you picking somebody from group B if you know you're doing group A? So group A is all I'm looking at. So what's the chance I pick somebody from group B? Well, there are 2 people in group B out of 1, 2, 3, 4, 5, 6, 7, 8 circled up, or 1/4. And that would be the answer. 2 8s, 1/4. Okay, you're welcome. Let's see. Okay, select the probability that is equal to probability of A and probability of B. Well, we already know probability of A and B. It's 2/14, or 1/7. Well, wait a minute. Hey, this one's 1/7 also. Yeah, so let's just mark that. Okay, you just match up the numbers. Okay. Oh my gosh, the cookies are out of the oven. I can smell them, or at least I think they are. All right, so we've seen things like this before. We're gonna toss a coin 3 times. We've done like where, hey, you draw 3 cards, or you toss a die 3 times. Remember that even, odd, even problem we did? Okay, so HTT, for example, means that you got heads on the first toss, then tails on the second, then tails on the third. And then they have all 8 possibilities here. Why are there 8? Well, because there's 2 choices each time, and 2 times 2 times 2 is 8. Okay, so event A, the last toss is heads. Okay, well, yeah, the third one is heads, third one heads, third one heads, third one heads. So looks like I clicked on, looks like that happens 4 out of 8 times, or you could put 1/2. For event B, at least 1 toss is tails. Okay, so anything with tails is something we're going to pick, and that's going to be 7 out of 8. And the last one, event A and B. The last toss is heads, and at least 1 toss is tails. Well, remember back in chapter, well, I don't remember when, 1 or 2, I think, we talked about sometimes you can look at the word and as being intersection. So which of these 8 categories do event A and event B have in common? Well, they're both marked there, and there, and there. Okay, those are the 3 that they have in common. 3 out of 8, at least I think so. Yeah, and that would be it. Oh, wait, there's more. That's only part A. Okay, I didn't know there was B and C. Suppose at least 1 toss is tails. Okay, so event B. All right, this will limit the possible outcomes. That's true. Okay, so yeah, so you wouldn't have head, head, head. So it would limit, but not much. From the remaining outcomes, so those other 7, check the outcomes for event A. Then enter the probability that event A occurs, given that event B occurs. So this given right here is telling me, oh, we're doing a conditional probability, aren't we? All right, so basically what they're asking us to do is probability of A given B. So let's see. Okay, so event A was the last toss is a heads. So so because B is the condition, they're only giving us the stuff that satisfies event B. Those 7 those 7 outcomes that we selected before. All right. So how many of those are event A? The last toss is heads. Well, that one, that one, that one. Hey, look, looks kind of similar to what we did on the third part of part A. Okay, cool. Now let's go to part C. Oh, but first I need to put in the probability. So 3 choices out of only, or 3 times I can have that out of only 7 possibilities. Okay. All right, now part C, the last part. Given the following probability, select the correct option. All right, what's the probability of A and B? Well, we already found that. That was 3/8. Okay. And we're going to divide that by the probability of B, which we found to be 7/8. All right. So we're going to say 3/8 over 7/8, which is 3/8 times the reciprocal, 8/7. The 8's cancel, and I get 3/7. Okay. So 3/7. Okay. Now, what's the probability of A given B? Well, we just found that 3/7. So, out of those 2 things, which one? What's going on? Well, obviously they're equal. They're both 3/7. So the point of this problem is to show that the formula for conditional probability is right here. That's the formula for it. They are equal. Now, like I did say before, I find it easier a lot of times to just kind of, just ignore the formula and just reason it out. Either way is fine. They're both great. But that's just me. Okay, so on this one, it says we're just going to figure out if events A and B are independent or dependent. But this time, they don't give us what A and B are, just probabilities. So we have to use those formulas. Okay, this is one of the few times that you absolutely have to. So 4 sets. Okay, now I'm going to look at their explanation because it has a lot of good information that, well, I was going to give you anyway. So it says two events are independent if the occurrence of one event does not affect the probability of the other. So if A occurs, the probability of B is the same thing as it would have been if A had not occurred. That's what they mean. We'll consider two events A and B such that the probability of A and B are both positive. If A and B are independent, then the following is true. Probability of A and B is equal to the product or multiplication of probability of A and probability of B. Well, we've been using that property a bit. I haven't needed to specify this rule before, but well, now we are. The probability that event, okay, so that is probability of A given B is equal to probability of A. Or conversely, probability of B given A is equal to probability of B. So these two right here are very much more clearly state what I was saying originally, that, hey, if the probability of A, if the two events are independent, then the probability of A doesn't change, even if B has happened, and vice versa. Okay, so we know that for part A, probability of A is 1/6, etc. And so we say, all right, well, the probability of B given A is still equal to the probability of B. Okay, 1/5 and 1/5. So yeah, it's true. They're independent. Okay, they're independent events. How about for part B? Okay. Well, based on what you're given, all right. So the probability of A given B is 1/5. And so what about the probability of A all by itself? Okay, what would B not having happened necessarily? Still 1/5. So yeah, independent. And then on part C, probability of A and B is 1/10. Probability of A times probability of B is 1/10. So yeah, the two events are independent. So everything's independent so far. But on this one, probability of A and B is equal to, okay, same formula, but they don't match up. So they're not independent. They are dependent events. So depending on what information you're given, you're going to use different formulas from right here. And that's really it. Okay, for this one, computing conditional probability using a two-way frequency table. Two-way meaning two different things being answered. So type of shirt and type of person. So at a school's open house, t-shirts and sweatshirts were sold. Each item was purchased by either a student or a parent. And then we've got 60 people or 60 items that were sold. Okay, so let parent be the event that an item randomly chosen from among those sold was purchased by a parent, no surprise. Sweatshirt is the event that a sweatshirt was sold. So what's the probability of sweatshirt? Well, again, probability means number of ways that the event can occur, or in this case, has occurred. Well, there are 9 plus 27, that's 36 sweatshirts out of 60 items. Oh, whoops, need the division sign. Write your answer as a decimal. So 36 divided by 60 is going to be 0.6 or 60%. All right, probability that you pick out of all these things going on that a parent and sweatshirt are chosen. In other words, a parent who bought a sweatshirt. Well, there are 27 parents that bought sweatshirts out of 60. So that's going to be 45% chance you pick that person. Or in other words, 45% of the people were parents that bought sweatshirts. Last one is probability of that you pick out of these 60 elements, that you pick a parent given that a sweatshirt was chosen. So in other words, we know we're looking at sweatshirts. So we are not worrying about t-shirts. So we're only looking now at these 36 people, 9 plus 27. And let's see, how many of them are parents? 27. And that is 75%. Okay, notice once again, the probability of, the probability of a parent, the probability of picking a parent is going to be, oh, whoops, that's back, is going to be 8 out of 27. That's 35 people. So 35 out of 60, which would be 58%. So that's probability of picking a parent. But the probability of picking a parent, given the condition that it's somebody who bought a sweatshirt, well, is 75%. So that probability changes, and therefore parent and sweatshirt are dependent events. They didn't ask us to specify that, but I thought I'd point that out. Okay, so now we've got the sales for each of 200 salespersons were reported 1 month. So these they're all going to add up to 200. All right. So then some of the salespeople took a sales training seminar, and the rest did not. The next month's results are reported in the following two-way frequency table. Okay, so all right, that's where these 200 people come from. So a salesperson, one out of these 200, is chosen at random from this group. Complete the following table and write your answers as decimals. Good thing I got my calculator handy again. So find the probability that the salesperson increased sales. Well, there are, let's see, 98 people who increased sales. Out of 200, 98 divided by 200 is going to be 0.49, 49%. So about half the people increased their sales. Okay. Now, some of them went to the seminar and some did not. Find the probability that the salesperson increased sales, given that she took the seminar. All right. So we're looking for probability of increased sales given that the seminar was attended by this guy. All right, so we're not looking at the no seminar people. We're just looking at the seminar people. And so how many of them increased sales? Well, 72 out of 96. 72 plus 24. And that's going to be 75% of the people. All right, very cool. Part C, there. Is there evidence that a salesperson who takes the seminar is more likely to increase sales than a randomly chosen person from the group? So, take a minute, think about it, pause the video, and see what you think is right, and then we'll check it here in just a second. Okay, hopefully you've had enough time there to check it out. The answer is the first one. Yeah, there seems to be a difference because the probability found in part B is much greater than the probability found in part A. Okay, and that's kind of it. Now you might ask the question, well, how much more does this have to be than this in order to be considered much greater? Well, that's beyond the scope of this course, to be honest, and it's not something you're gonna have to worry about. Anyway, yeah, that's how it's done. Okay, on this one. Okay, we're talking about helping people. So we notice, okay, the probability, they give us the probability that a senior citizen suffers from a sleep disorder is 90%. And the probability that one of them suffers from anxiety is 7%. And the probability that one of them suffers from sleep disorder and anxiety is 6%. Okay, so I find it easier if I write it that way. So it says find the probability that a senior citizen suffers from anxiety given, oh, so there's my conditional probability bar, that he or she has a sleep disorder. Okay, once again, we're going to need that formula. The formula is probability of the two of them together with the word and divided by the probability of that second thing, the condition. Okay. So let's see, that would be 0.06 divided by 0.9. And that's going to be 0.07. So 7% chance that you pick a senior citizen at random, they suffer from anxiety. If we're only looking at people with sleep disorders. Okay, now how about part B? What's the probability that of someone, a senior citizen that suffers from a sleep disorder, given suffer from anxiety? So once again, we do probability of the two of them added together. And that are the same thing. Okay. It's just, yeah, both of them occurring. Divided by the probability of the condition, that second thing in the statement. So that'll be 0.06 again, but this time divided by 0.07, which is going to be 0.86. So 86% chance of that one. Whoa, that's quite a bit different. But that's how it's done.